The question of which country boasts the best electrical installation practices sparks lively debates in the comments section of numerous eFix videos. Naturally, we're inclined to favour the standards and practices of our own regions, considering them the norm. The widespread use of flexible plastic conduit in mainland Europe strikes many in the UK as somewhat peculiar. Conversely, our European friends find the UK's penchant for encasing electrical equipment in metal equally bizarre. In the UK, our power cables are sheathed in steel armour, even when positioned several metres off the ground. Our metal conduit is so robust it requires specialised equipment, and we employ threading techniques akin to those used in plumbing to assemble the system. This approach even puzzles American electricians who, despite their own affinity for the use of metal in electrical installations, find the concept of armour-plated electrical conduits bewildering. Europe might be united on one thing, however: American wire nuts are a mystery worthy of their own video. Despite years of attempts to standardise electrical installations worldwide, we still cling to the traditional methods. Mainland Europe prefers lightweight plastic conduits, while the UK designs its electrical containment systems to endure well into the next century. Yet, occasionally, the speed of innovation surprises us, leading to default acceptance of new practices. Solar panels serve as a prime example, with the entire world adopting a universal connector and cable standard. However, just don't try to mix connectors from different manufacturers. If you're interested in witnessing a classic example of British commercial electrical infrastructure, look at any underground or multi-storey car park. These installations were engineered to endure for decades. However, what wasn't anticipated was the need to accommodate hundreds of thousands of EV chargers within the next 10 years. This is where our use of metal containment presents a problem. Its lack of flexibility makes it difficult to modify,
Struggling there a bit, Gary. No.
and installation is a time-consuming process. This poses a significant challenge since most car parks that require EV chargers, such as those in office buildings or residential complexes, are already constructed. The standard method of installing EV chargers involves wiring each charger independently to a distribution board, demanding significant infrastructure such as cabling, containment, and sizable power distribution boards. This approach is not only time-consuming, but also disrupts the operation of car parks during the electrical installation process. So perhaps it's time for a new approach. This is where the Podis distributed power system from Wieland Electric comes in. It's an approach that will be familiar to electricians who fitted busbar trunking in factories or underfloor busbar trunking in offices. The flat cable serves as a busbar designed to be mounted directly onto the ceiling or walls of the car park. At designated charge points, tap-off boxes securely clamp around the cable, facilitating a connection to each electric vehicle charger. The ingenious aspect lies in the method of establishing an electrical connection to the busbar cable. After positioning the tap-off box around the cable, there's no need for any cutting or terminating any cables. Instead, by driving these insulation piercing screws directly into the cable, you effortlessly complete the connection. Now, of course, when we say screws, these aren't just any old screws. Wieland define this as insulation piercing technology, and the screw itself has been very carefully designed to make the exact contact point to the cable, and you can't drive it any further than that. So the risk of getting this wrong is absolutely minimum. Just follow those torque settings. The sealing of the connections and enclosure lid achieves an IP65 rating, rendering the system perfectly suited for exposed multi-storey car parks and combating the dust found in underground facilities. If you've worked on wiring a commercial office block, you're likely familiar with Wieland Electric, renowned for inventing the GST-18 connection system. This is a favourite for modular wiring in lighting control systems due to its plug-and-play convenience. And a similar approach is used in the Podis system, where tap-off boxes can be fitted with waterproof RST connections, further reducing the wiring time. The Podis system's true advantage lies in its flexibility to parking facility operators. Initially, the busbar cable can be installed, allowing for the effortless addition of charge points in response to demand. This is achieved by adding a tap-off box, or alternatively, tap-off boxes can be pre-installed next to each parking bay, enabling EV chargers to be easily connected using the RST connector system. You can install individual tap-off boxes for each parking bay or opt for a twin tap-off box to serve 2 spaces. The RST connectors are available pre-wired with 0.5 to 3 meters of cable ready to connect straight into an EV charger. RST connectors are easy to plug together but require a tool for removal. The ability to disconnect locally also helps with the initial and periodic electrical testing. The busbar system, rated at 63 amps, uses 16mm squared conductors arranged in a 3-phase neutral and earth configuration. Its cleverly designed cable is keyed to prevent incorrect installation of the boxes. The system is versatile, allowing for power through connection modules that resemble tap-off boxes. These modules can be positioned along the cable, facilitating the connection of a 16mm squared supply cable. End feed boxes are available for larger cables, such as steel-wired armoured ones, offering ample wiring space for ease of installation. You only actually need to strip cable when connecting to end feed boxes or fitting an end cap to maintain the system's IP65 rating. End caps easily screw onto a prepared cable. A specialised trimming knife simplifies the stripping process by precisely scoring the cable's outer sheath, allowing for its easy removal without damaging the conductor's insulation. If you do make a mistake and install a box in the wrong location, boxes can be removed and the screw entry point sealed with a special repair patch. Cables are supported by metal straps, enabling compliance with the premature collapse requirements of BS 7671. Despite its sleek design, the cable boasts an exceptional durability. It meets the IK10 standard for impact resistance, and the fully assembled system achieves an IK09 rating. You might think that 63 amps isn't sufficient to charge a full apartment block's worth of electric vehicles. After all, this amounts to the capacity for only 6 7-kilowatt single-phase chargers. However, the real bottleneck for EV charging often lies in the power supply available to the building, not the cabling to each charger. In practice, not every EV owner arrives home with an empty battery, nor does every driver cover 200 miles daily. And additionally, there's no immediate need for everybody to start charging as soon as they get home. By integrating the Podis system with advanced chargers such as those from Zaptec, Easy or Garrow, which include load management, or using a charger that supports third-party OCPP platforms such as Wevo, it's possible for a single Podis cable to support 20 or 30 charging bays. This setup is ideal for locations where visitors spend extended periods, such as shopping centres or leisure facilities, offering a versatile and efficient charging solution. Now, we often receive inquiries about EV chargers and busbar systems, especially on how you can connect a 6mm cable to a 16mm busbar safely without overcurrent protection at the point of connection. And questions also arise about the optimal location for residual current devices and, of course, which type to use. To address these topics, we'll provide links to the Q&A videos that delve into these issues in the description, along with a link for those interested in exploring the Wieland Podis system further. In the UK, the Podis system is available ex-stock from our friends at Doncaster Cables. The key to a successful and compliant installation lies in how you apply the wiring regulations. Many common issues are solved by the charger itself. For instance, the Zaptec Pro and Garrow Entity chargers we've recently reviewed feature full RCD and overcurrent protection within the charger. Wieland offers a comprehensive solution with its range of DIN rail enclosures for those using chargers that need external circuit protection, load management or communication equipment. These also feature the pluggable RST connections, ensuring a seamless wiring process. If you're involved in installation and specifying EV chargers in car parks and shared spaces, we believe the Wieland Podis offers an outstanding solution. However, car park operators currently face some additional challenges due to the new payment law outlined in the Public Charge Point Regulations 2023. Our video on screen now demonstrates how to comply by integrating a payment terminal into chargers like this one.